One project dropped in late 2025. And within weeks, at least 7 different teams looked at it and said, I can do this differently. Some wanted it lighter, some wanted it safer. One team rebuilt it entirely in a language most developers have never touched. One team did not build a personal assistant at all. They built something in a completely different category that just happens to share the name. In this video, I'm going to walk through every single tool in this family, including one that barely anyone is covering, put them side by side across performance, messaging support, philosophy, and benchmarks. And by the end, you will know exactly which one fits your situation. Let's start with the original. OpenClaw is the tool that started all of this. Written in TypeScript, it connects to more messaging platforms than anything else in this family. It has voice support, a leave canvas, and companion apps across all platforms. 140,000 GitHub stars. It is the most complete version of this idea anyone has shipped. And also the heaviest, sitting at over 1.5 gigabytes of RAM and a code base of 430,000 lines of code. Everything else you're about to see was built in direct response to that number. The first to react was ZeroClaw. Written in Rust, not because Rust is fashionable, but because every subsystem in ZeroClaw is a swappable trait. Provider, channel, tool, memory, you can replace any of it without touching the rest. It also has the most sophisticated memory system in the entire family, hybrid vector and full text search, optional Postgres support, and a built-in migration tool if you want to move from OpenClaw. Under 5 megabytes of RAM, boots in under 10 milliseconds, 18,000 stars. This is the one you reach for if production reliability actually matters. Then Saipade, a hardware company from Shenzhen, shipped PicoClaw. Built in the Go programming language, designed specifically to run on their $10 development boards. I did a full breakdown on this one in a previous video, but the headline is under 10 megabytes of RAM, boots in under a second, and 95% of the core code was written by an AI agent during a self-bootstrapping process. 19,000 stars in under 2 weeks. The hardware angle is real. This thing runs on chips that cost less than a coffee. NanoBot came out of Hong Kong University. Written in Python. Around 4,000 lines total. That number is the entire point. NanoBot is not trying to compete on features or performance. It is optimizing for code you can actually read and understand. 11 supported language model providers, 17,000 stars. If you want to understand how an agent loop actually works under the hood, read this code base. It is the most accessible entry point in the entire family by a wide margin. NullClaw is where things get extreme. Written in Zig, a language that produces a 678 kilobyte static binary. No runtime, no garbage collector, no dependencies at all. Starts in under 2 milliseconds. Uses around 1 megabyte of RAM. Despite that binary being roughly the size of a small image file, NullClaw supports 22 language model providers and has over 3,200 automated tests, more than any other tool in this family. It also has hardware peripheral support for Arduino and Raspberry Pi. 5,000 stars, but do not let that fool you. This is technically the most impressive build in the group. IronClaw is the security first one. Also written in Rust. Every single tool runs inside a WebAssembly sandbox, which means a malicious input from a tool result cannot touch your credentials or your system. Credentials are never exposed to tools directly. Multi-layer prompt injection defense is baked in at the architecture level, not added on top as an afterthought. If you are running an agent that reads external content, browses websites, or handles sensitive business data, this is the one built with that threat model in mind. TinyClaw is the odd one out, and I want to spend a moment on this because it gets miscategorized constantly. It is not a personal assistant. Where every other tool in this video is one agent talking to you, TinyClaw is a team of agents talking to each other. A coder, a writer, a reviewer, each one passing work to the next with a live dashboard so you can watch the collaboration happen in real time. Different problem, different architecture, different use case entirely. Only 2,300 stars right now, but the category it occupies is genuinely distinct. And then there is the one that almost nobody in this space is covering, NanoClaw. Written in TypeScript, 500 lines of core code. You can read the entire thing in under 10 minutes and understand every line. What makes it different from NanoBot, which is also minimal, is the architecture. Every agent in NanoClaw runs in its own isolated container. That is container isolation baked in by default, not configured after the fact. It supports agent swarms, which puts it somewhere between a personal assistant and TinyClaw's orchestration model. Built on the Anthropic SDK directly, 12,000 stars and growing. This one is worth watching. Now let's look at the numbers side by side, because this is where the language choice stops being academic and starts being the actual story. OpenClaw in TypeScript uses 1,520 megabytes of RAM. NanoBot in Python uses around 100. The moment you move to a compiled language, the picture changes completely. PicoClaw in Go drops to under 10 megabytes. ZeroClaw and IronClaw in Rust sit under 8. NullClaw in Zig hits 1 megabyte. That is a 1500 to 1 difference between OpenClaw and NullClaw. On startup time, OpenClaw takes almost 6 seconds. NanoBot on a cold Python runtime takes 30 seconds. ZeroClaw, IronClaw, NanoClaw, and TinyClaw all boot in under 10 milliseconds. NullClaw in under 2. The language you write in is not a style choice in this family. It is the hardware you can deploy to. The channel support diagram is interesting because it tells you a lot about who each tool was actually built for. Telegram is the one channel every single tool supports, all 8 of them. If you are picking any of these and you use Telegram, you are covered no matter what. OpenClaw has the broadest Western platform coverage. It is the only one with iMessage and Microsoft Teams natively. ZeroClaw actually has the widest overall coverage at 11 platforms. PicoClaw and NanoBot both lead on Asian platforms, which makes sense given where they were built. IronClaw has deliberately limited coverage, 4 platforms. Fewer integrations means fewer attack surfaces. That is a security decision, not a gap. TinyClaw only supports 3. It is an orchestration tool and does not need more than that for its use case. The philosophy section is where this gets most interesting, because half these tools are doing the same thing and half are doing something completely different. OpenClaw, ZeroClaw, and NullClaw are all versions of the same idea, a fully featured personal assistant, just at completely different points on the resource spectrum. NanoBot is not competing on any of those axes. It is optimizing for code you can read. IronClaw is optimizing for security above everything else. PicoClaw is optimizing for a specific hardware ecosystem. NanoClaw sits between minimal code and container safety, auditable by design. And TinyClaw, as I said, is not even in the same product category. So the answer to whether these tools are more similar or different, the core concept is the same across most of them. The philosophy and the target user diverge very significantly. On the multi-dimensional benchmark radar, if you score all 8 across performance, speed, minimalism, security, channel coverage, and community, NullClaw comes out on top overall at 8.3, ZeroClaw second at 7.7, IronClaw third, NanoClaw fourth. But there is an important caveat on those numbers. TinyClaw scores lower on the radar because it is being measured as a personal assistant when it is actually an orchestration tool. That lower number does not mean it is inferior. It means it is solving a different problem. The code-based picture is striking when you visualize it. OpenClaw at 430,000 lines versus NanoClaw at 500. Same core agent loop, a ratio of over 800 to 1. So which one? If you want the full experience with every channel and every feature, OpenClaw is still the answer. Nothing else comes close on coverage. If you are deploying to cheap or edge hardware, PicoClaw or NullClaw depending on how extreme you want to go. If production reliability and modular architecture matter, ZeroClaw. If security is the non-negotiable requirement, IronClaw. If you want to learn how agents actually work under the hood, read NanoBot's codebase and run it while you do. If you want minimal auditable code with container isolation and you do not need all of OpenClaw's weight, NanoClaw is the underrated pick in this group right now. And if you want multiple agents working as a team rather than a single assistant, TinyClaw is the only one doing that. This entire ecosystem went from 1 tool to 8 in a matter of weeks. The ideas behind these projects, the agent loop, the tool calling, the memory systems, those are not going away. What is happening right now is the same thing that happened with web servers, databases, and messaging queues. A concept proves itself, and then the community rebuilds it in every language, for every hardware constraint, with every philosophy imaginable. We are watching that happen in real time with AI agents. Worth paying attention to. Comment what you think about these tools and subscribe for more updates that I upload daily.